Hello, chemistry students. Today we are going to talk about the types of chemical reactions. By the end of this video, you should be able to recognize a combination, decomposition, single displacement, double displacement, and combustion reaction. As a review, I would like to go over how to read a chemical formula. We covered this a little bit last semester, but let's go over it one more time. You start with the reactants on the left. Those will react together to form products. Okay, so we have a couple different examples of different types of reactants and products down here at the bottom. We have two elements, iron and oxygen, who react together to form a molecule. Okay, so iron is all by itself, and oxygen actually has this little tube below it. Now, remember from last semester that we have 7 unique elements. I remember them by remembering the phrase Hänkelbrief, but if you see any of these 7 elements in a formula, or you see their name and are asked to write the formula, always remember that they exist with a buddy. There's always 2 of them. Now, the other thing I want to remind you about is when you're writing a molecular formula like iron 3 oxide, it needs to be neutral. So the ion oxygen has a charge of -2. Iron, we learned from the name, this form has a charge of +3. So there needs to be an equal positive and negative charge on this molecule. So we do that by dropping and crossing the charges and writing them down here as subscripts. Okay, so 3 times 2 is +6, and -2 times 3 is -6. This means that overall, the molecule is neutral. You're going to need to remember how to write a neutral molecule when you are writing chemical formulas. Okay, so the first type of reaction is called a combination reaction. This happens when 2 or more substances react to form a single new substance. So our products form this reactant, and you'll be able to recognize this when you see it because there is a cation reacting with an anion to form one molecule. The opposite of a combination reaction is a decomposition reaction. You would have a molecule reacting or to form 2 separate products. This is a single displacement reaction, and you start with one molecule and one lone element, and they react to form a different combination. So what happens in this situation is C replaces A, and A moves out by itself. You're going to have to be able to recognize whether C would replace the cation. In this case, it could also be written like this: AB plus C forms AC plus B. Now, in this situation, C actually replaced the anion, and it moved out by itself. Both of these situations represent a single displacement reaction. Next is a double displacement reaction. So in this one, you have AB plus CD that react to form AD plus CB. So here you have 2 cations and 2 anions, and they're already bonded together. And then when you mix them, they switch. So Here we had B switch to join C and D switched to join A. Finally, there's a combustion reaction, and in this reaction, a chemical change will occur and an element will always react with oxygen, and it will often produce energy in the form of heat and light. So you're going to be able to recognize a combustion reaction when you see a molecule reacting with oxygen to form carbon dioxide and water. The highlighted reactants and products will never change. So if you see this type of reaction and you see these products and this reactant, you will know you are dealing with a combustion reaction. Okay, so let's practice. Let's identify these following reaction types. This is a combustion reaction. This one represents single displacement. This is a decomposition reaction. Here we have a combination reaction. And now this is double displacement.